Logarithms can be used to identify nonlinear relations between two variables, including between two random variables. If the variables x and y are thought to be related to an equation either of the form y equals ax to the n or y equals kb to the x, take logs of both sides to form a linear equation. In this example, it was believed that the relationship could be modeled by the equation h equals kf to the power m. You need to think very clearly about which letters are the variables and which are the constant. In this one, f and h are the variables. So when we take logs of both sides here, and we get the log of h is the log of k plus m times the log of f, the variables are going to be log h and log f. In the exam, you won't need to find the equation of the regression line, but we'll do it just on a calculator to see how the first one works. So choose menu 6 and then y equals a plus bx. And because the variables we're working with are log h and log f, what you need to enter into the x column are the logs of the f values. So enter log 12.3, log 13.1, and so on. And into the y column, put log 20.5, log 20.4. I'm using base 10. You could use any base as long as you use the same one all the time. I'm using base 10. The numbers which you'll see on the screen are these ones on the display. And in fact, if you did plot them on a scatter diagram, the points would lie close to a straight line. R, which is a measure of how close the points are to a straight line, is actually 0.98656. That's close to 1. So a regression line using this equation will give dependable predictions. If you then get the values of a and b for the regression line, you'll find a is 1.138, b is 0.1605, and so you can put these into the equation y equals a plus bx. In the exam, you'd be told the regression line is y equals 1.138 plus 0.1605x, where y is the log of h and x is the log of f. So the gradient is 0.1605, and in our equation here, the gradient is m. So m is 0.1605. The intercept, 1.138, in our equation, that's the log of k. So log to base 10 of k is 1.138. So 10 to the power of 1.138 will give us k. And then we can write h as a function of f. And if we know a value of f, we can find h. Because we're dealing with random variables, what we can say is that on average, the plants will be 17.2 centimeters high with 4.0 milliliters of fertilizer.